All right. Well, hello, everyone. Thank you for having me. A fair bit of warning, you're going to be seeing me quite a lot at this conference. I have 4 sessions. For some reason, I submitted 4 talks, and they accepted all of them. I'm not sure if that's a good thing or a bad thing. But let's see. Let's see how this goes. Well, it's 3.5. I have 1 talk I'm doing with a colleague of mine. We're going to be talking about something that, if you're a software developer, it's going to be more important for you going forward. And it will be more important in the sense that you should be aware of it. You should be consciously working to make your work and your code better in terms of security, not necessarily that you're going to have to be responsible and all security experts. So the goal of this session really is to give you like an overview of what's going on in the software security space across a lot of efforts, a lot of projects, a lot of organizations trying to solve this in different ways. And hopefully you will take 1 or 2 things out of this. My name is Abdel. I live here in Sweden, Stockholm. I work for Google. I'm a cloud developer advocate. I host a podcast called the Kubernetes Podcast. That's because that's one of the main projects I work on. But my background is really in infrastructure and security. That's my Twitter, or X, or whatever they call it these days. And yeah, so today's topic is the software supply chain security topic, which is kind of a buzzword, right? Pretty much like cloud is a buzzword, and serverless is a buzzword, and every other word that we're using in our industry is actually just a buzzword, an overloaded term. But let's try to understand what it means. This is what we mean by software supply chain. Some of you might look at this and say that's the CI/CD. That's essentially what it is. The software supply chain is the process by which you get software from where you produce it, typically your laptop, into production. It's called the software supply chain because the people who invented this term just took supply chain from the food world, how we get food from where it's produced to our table, and just applied it to software. Because shipping software or shipping libraries pretty much follows the same process. You start with a bunch of ingredients, that's your code, right? You depend on other people. When you are in the food supply chain industry, you're just producing one thing and one thing only. You do tomatoes or cucumbers or fish or meat or whatever. In order for people to be able to eat food, they will have to take food from multiple sources. That's fairly similar to how we do software, right? You write your own software, but then you also depend on other people's software. Then you take that software, you build it with all the dependencies you download from the internet, you package it, and then you ship it to where it's supposed to be shipped. And I think something that probably people don't realize a lot is that also these dependencies, they're also get shipped to you the same way you are shipping your software to whoever is using it. They also follow the same supply chain process. They probably have a CI/CD, they probably do builds and tests and QA and all that stuff. And if we really want to be very honest with ourselves as developers, your dependency square is probably much, much bigger than your source code square, because you are probably writing actually less code than you are depending on other people's code, right? No one today is writing a math library or a curl library or an HTTP server. You're just importing it from somebody else, right? And that's good and frightening at the same time. There are a bunch of studies that have been done. One that have been done by Sonatype in 2021 called the State of Software Supply Chain. And it says that 600, and we're supposed to see a surge in OSS type attacks by up to 650%. Another study said that 81% of commercial code bases have some sort of vulnerabilities. Commercial code bases is off-the-shelf software. It's third-party software that is not open source. And that 45% of all organizations worldwide will experience some sort of software supply chain attack by 2025. Some of those attacks happened very recently, and we all remember them. How many people remember Log4j? Everybody almost, right? SolarWinds is probably less popular. SolarWinds is a company in the US that sells monitoring software. They were attacked. Somebody downloaded a dependency from the internet that had some vulnerability. And one of their customers was a company called Continental Pipeline, which is the company that supplies the entire east coast of America with gas, oil. And that's basically, they were crypto attacks. So their computers were locked out, and they had to pay a ransom to get their computers back. And the amplitude, the magnitude of these attacks is actually getting slightly bigger than just a bunch of people sitting in a basement trying to attack another bunch of people sitting in a basement. It's getting so big that it's actually impacting real life. Because when the SolarWind attack happened and Continental Pipeline announced that they were under attack, there was huge lines in gas stations because people were freaking out that there would be no more gas. And people were lining up to be able to buy gas, right? I'm going to talk about one that happened closer to home without mentioning names. But yeah, those attacks are happening more and more. So the one that happened here, I'm not going to mention the names, but I think you're probably going to figure out which one it is. It's a big supermarket chain in Sweden. They were under attack last year. They had to close 700 of their stores anywhere between 1 day to 6 days. And what happened to them is that they subcontracted the management of their self-service checkouts, which we have them here in Sweden, right? Like every supermarket have a self-service checkout. So they subcontracted the management of those machines to another company, and that company was using a third software. So the supermarket, the customer, was not even aware that this software was used to manage their systems because they just let somebody else do it on their behalf. So that company making the off-the-shelf software, the closed-source commercial software, were attacked. They downloaded some dependency from the internet that has a vulnerability. They didn't realize it. Mistakes happen. They took that patch. They distributed to their customers. One of them is the middleman, woman, whatever, and that middle person took those patches and supplied it to their customers. And this illustration, although I think that's not everybody is a fan of it, but the point of this illustration is to demonstrate that with software supply chain attacks, you can have a ballooning effect where you can target one library used by one company, and because that software gets distributed to other customers, or in the case of open source, that library gets distributed to other people, you can get your attack surface growing up because of how we depend on each other in terms of libraries and open source and stuff like that. There are two more examples I can give very quickly. One is also closer to home, Maersk, the Danish company that does maritime transport. A few years ago, they were actually under a huge attack where through software supply chain type attack, one of their subdivisions in Ukraine got injected with a worm, which then spread inside the network in the company, and Maersk was down for like an entire month, I think, or like a few weeks. And that impacted the global freight because one of the effects of this problem or this attack was that they have automated license plate scanning in ports. When trucks are driving into ports, the license plates are scanned automatically, and then a printout paper tells the driver where to drop the load or the container. That stopped working because the network was not working, and they had to depend on very bad internet connections in Africa, because one of the things that happened to them is that they have an Active Directory tree inside the company, which is a bunch of Active Directory instances that replicates from each other. And they had one data center in South Africa that was actually disconnected from the rest of the network for a couple of days. So that worm did not spread to that instance. And they could manage to recover their Active Directory by shipping a hard drive from South Africa to London and recovering from that hard drive. If you have done any system administrator type work, which I have done before, you know what I'm talking about. No backups and Active Directory replicating from each other is like the worst system administrator nightmare. And I can go on and on. There have been a lot of examples like this, right? And that's because the way we build our software supply chain systems today is basically vulnerable to a lot of attack vectors because it's big, it's complicated. Typically, a CI/CD system is under the responsibility of multiple people, multiple teams, and just it takes only one mistake to do the wrong thing. You could start by injecting bad code. I think that we don't like to admit this in our industry, but we just run in the tech industry with the assumption that every single developer we hire is good and that they are actually trustworthy. There are countries where doing background checks for people working in tech industry in certain industries is mandatory. Banking, defense, stuff like that. Not every country does that. So who tells you you didn't hire somebody who is trying to actually hurt you from inside? maliciously write bad code, or just download code from Stack Overflow, right? Which I think everybody here have done before. You could have a compromised source control system, just one wrong permission on your Git repository. You could have a compromised build system. And this is especially a problem if you don't actually maintain your build system. There is a company that does manage CI. I'm not going to mention the name, but you probably figured out which one. They leaked their AWS keys last year. And it took them 2 weeks over Christmas to figure out what they have done that. Again, through compromised, misconfigured Git systems. And the problem is that they didn't leak their own keys. They didn't leak their customers' keys. They leaked their own keys, the ones they use to run their own managed CI system, right? So you are using a managed CI with the assumption that it's secure, and then one mistake, and then you're exposed, right? You can have bad dependencies. You're just downloading dependencies that have bad backdoors or have vulnerabilities built in. And I can go on and on. But basically, if every single step in this entire system, something can go wrong, and it can just screw everything. I think, before I move on, I think the whole point of using the term software supply chain, again, I was not sitting in the room when this term was decided to be used on, so I'm just assuming here, is because in a very similar way to supplying software to production, supplying food to people is also extremely vulnerable system, right? If you are a bad, malicious actor trying to hurt people intentionally, you could just compromise the source of water that people are drinking, right? You can just drop something in the water. It doesn't get filtered out. People get sick. You could compromise the crops. You could compromise the fish or the chicken or the meat or whatever they are eating, right? So in a way, you could concentrate your attack effort on a single point, but because we all depend on each other in the way we produce food and also in the way we produce software, you could get your attack amplified to a very large extent. Make sense? Cool. So, a few years ago, people realized that these kind of attacks are becoming problematic, and there have been a bunch of efforts. The two main ones are shift left, as like an effort to try to reduce the attack surface of software, and zero trust. So shift left is basically a term that is copied, if you want, from the DevOps movement. The whole point of the DevOps movement is the shift left, is shifting the responsibility of production back to developers. With the security aspect of software is shipping the responsibility of security. I don't really like the term shift left in security because it just makes it suddenly look like we want to make every single developer a security expert. The better way I would describe it is, instead of shifting responsibility left, is shifting awareness and trust left. So shifting trust means trusting but verifying, making sure that the software you are putting in your system through your CI/CD pipeline comes from a trusted source. And that can be done through sign-in, that can be done through authentication, and a bunch of other ways. Shifting the awareness left is actually making sure people know what they are doing. That comes through vulnerability scanning, static code analysis, things like that. Making the developers aware of what they are doing. And hopefully also trying to make that feedback loop as fast as possible. Zero trust is essentially coming from the security space in the network. I'm an infrastructure engineer, so I have done some zero trust work, which essentially means if you have a distributed system, you don't blindly trust that every single component in the distributed system is who they claim they are. So if you have a microservices-based system, that could mean things like authentication and authorization at every single step in the entire system, and not only at the edge of the network, which is how typically people do microservices. So a few years ago, this effort called Sghiouar got started. It's an open source project that was created in collaboration with the OpenSSF, the Open Software Security Foundation, which is under the Linux Foundation. It's a sister organization to the Linux Foundation. They collaborated with a company called ChainGuard, Cisco, and a bunch of other companies. And they came up with a bunch of tools and frameworks. One of these frameworks is a framework called SALSA, which starts for security levels of software architects. So SALSA, what it is, it's a framework. It's a checklist-based framework, which has a bunch of steps across the entire supply chain. And then as long as you are meeting those requirements, you are supposed to be compliant with one of the levels. I'm going to show you quickly how Salsa looks like. You can see here on the left side, you have all the requirements. The requirements are split into 4 categories: source, build, provenance, and common. And then you have Salsa level 1, level 2, level 3, level 4. And the point here is as long as you are able to check all the boxes for one of the requirements, then you are compliant with one of the levels, right? You can take the most simple example, or the most straightforward example is Salsa level 3. It just means you have version source control, so Git, I guess. You have versioned history or verified history. You can retain your history for a certain amount of time. So commit history is stored for up to 18 months. You have a build system which is scripted, ephemeral. Ephemeral means you don't execute 2 builds in the same worker, essentially, etc. I'm not going to go through all of them, but this is Salsa. And there are actually more and more companies today trying to take Salsa as a framework and make their build systems and their delivery systems compliant with one of the levels. In my opinion, level 3 is the one that is the most straightforward to aim for. But yeah, any of these levels work. This is Salsa version 0.1, which was the first version. They released a very recent version called Salsa 1.0, which focuses only on the build part of the system. So it ignores everything around source control, etc. It just focuses on the build part. So that's Salsa. They also create a bunch of components. Some of them are managed services. Some of them are open source tools. We're going to look at Cosign today, which is one of my favorites. It's a command line tool to sign and verify the signature of OCI images. OCI stands for Open Container Initiatives. So that's the standard that every single container tool builds toward. So as long as your image is OCI compliant, you can actually use Cosign to sign it and verify the signature. I'm going to show you a demo later. They have an they have like an authentication server. They have a CA, certificate authority. So with Cosign, you can basically use any cryptographic key, any asymmetric public private key, but you can also use the certificate authority by SigStore to download and use those keys. And then you have the other one called Recore. So Recore is a transparent ledger. It's a public transparency ledger. When you are using Cosign to sign artifacts, Cosign can optionally upload an audit trail to Recore to say these artifacts have been signed by this person and this public key. And then you have a public trace of what have been signed by who and when. Make sense? So these are components. You can dig into them. I'm not going to go through the details. This is what SigStore version of software supply chain security looks like. This is how they envision their tools to be used. So basically, but before I move on, these tools or these components can all be used separately from each other. They're all open source, right? So they can all be used separately from each other, or they can put together. What they are providing, what SigStore is providing to the public, is tools that can be used for open source software, right? So if you're releasing your software in open source space, you can use all this stuff for free. And this is how they think about it, how it could be used. So as a developer of an open source artifact, I can use Felucio to download the certificate. I can use OpenID Connect for authentication. OpenID Connect is already used by the Linux Foundation for authenticating users, so it's the same system. Then I take my, my artifact, I sign it using the certificate that I downloaded. The signature gets uploaded to the Recore transparency log. And then I publish the signed artifact. Then as an end user who is going to use this artifact, I have a way to either check the transparency log to verify that the artifacts have been signed, or I can actually download the artifact and then download the public key and verify the signature of that artifact. This is a very complicated way to just say, you know, when you're downloading a command line, sometimes you have an MD5 sum file or a SHA-256 file that you can also download. And you download your file with your ISO, Ubuntu ISO file, your kubectl command line. And then you can use just a simple command on your computer to say, this is my file, this is the signature, have this file meets the signature. If yes, then you know you're downloading the legitimate file. This is the fancier way of doing the same thing. So with MD5 sum or SHA-256, you are verifying the signature of a static file. this thing uses just certificates, authorities, and public-private keys to exactly do the same thing. Have an artifact being issued by the people, the group, the team that says they have issued it. Simply. Make sense? I'm going to show you a demo. It will be hopefully more clear. In addition to that, they introduced this thing called SBOM, Software Bill of Material. The most straightforward way to explain what SBOM is, and I'm sorry for using food as an analogy just because I like eating. Like imagine you are making Swedish meatballs. To make Swedish meatballs, you need ingredients and you need a recipe, right? The ingredients are the meat, the bread, the milk or cream. The ingredients is whatever your mother uses, and I know that every single Swedish mother have their own recipe, and no one would ever agree that the other people's recipe is the right one. But it doesn't matter. You have your ingredients, then you have the recipe. The recipe is the steps you follow to actually make the dish, right? To go from ingredients to final dish. In software, your ingredients are your libraries, your dependencies. Your recipe is the steps you have used to put those libraries together to produce the final artifact. So SBOM is the ingredients. Make sense? There are two standards for generating and storing SBOM. They're called CycloneDX or SPDX. They're just text files, and in these text files there is a standard format which basically lists all the dependencies, all the files, etc., etc. And there is also ways where you can take an SBOM itself, generated, sign it, store it, verify the signature of the SBOM, because it's just another artifact. It's just a static text file, so you can also sign it, and then you can verify the signature and all that stuff. So putting these two things together, Salsa is the way for you to make sure that your software supply chain system meets certain security requirements. SBOM is the metadata that allows you to know where an artifact came from and hopefully be able to trace it back to its origins. These are not separate frameworks. They are actually complementary frameworks. They can work together. Before I move, do I have a slide here? Yeah, before I move to the demo, SBOM specifically is going to be extremely important in Europe because the European Union have actually passed requirements that by 2025, I think, every single company operating in certain sectors, that's energy, healthcare, finance, etc., have to actually generate and store SBOM for their software and be able to provide it to the regulators on demand. I think it's called the NIST, NIST1 and NIST2. These are the two new kind of directives. You know, the European Union does not issue laws, they issue directives. And then those directives have to be retrofitted by EU members to turn into laws in each country, right? So this is going to be very important going forward for people who live in Europe. So let me show you a little bit how this could look like, right? So I have a fairly straightforward demo. How am I doing on time? Oh, okay, I have time. I might finish a little bit earlier, but like I want to leave time for questions if you have any questions. So let's see how we do this. I'm just gonna build this like very simple app. Just like a Docker hello world kind of demo. And hopefully this is not gonna take a very long time. I should have done this before I came on stage, but anyway, doesn't matter. All right, just give it a second. Can drink some water. Oh, okay, this is gonna take some. But basically what I'm gonna show you is how can we use cosign with a key to be able to sign and push the signature of that image to the artifact registry and then later on verify it. So that's the purpose of the demo. It's very basic, but it's just to give you an idea. So I have my image here, which is hello world. I'm just gonna tag it with a tag. For those of you who are not used to this syntax, I'm just tagging it with the, this is Google Cloud Artifact Registry URL. You could tag it with a Docker Hub. You could tag it with your own JFrog instance. It doesn't really matter. Because all this stuff is built toward the standard, which is called the OCI, the Open Container Initiative Standard, right? So I'm going to push my image. So I'm just doing a Docker push and then taking the signature. So hopefully this will also go through. Let me show you real quick. So this is Google Cloud, for those of you who have never used it. This is artifact registry. So this is where we store artifacts, containers, whatever kind of artifacts. So this is my image here. It's uploaded. It's just a single, simple image. And it only has 77 vulnerabilities. It's not too bad. Anyway, so what I'm going to do is I'm going to not do that. I'm going to actually use cosign to sign it. So this is what I have to stop to explain a little bit what's going on. So I have cosign here. I call cosign with the command sign. Is it visible in the back? Do I have to make it a little bit bigger? No, it's good? OK, cool. So I have cosign with the flag sign. I have a -- key, that's the second line. And you see in the -- key, it says GCP KMS. GCP stands for Google Cloud Platform. KMS means key management system. Every single cloud provider have a key management system. And cosign is actually built to work with all of them. So it supports AWS, it supports Azure, and it supports, well, the major one. And it also supports your own keys. So you can also pass your own key, and it will just work. So that's the URL to my key. And then the third line is the container image itself, right? And so what this thing will do is, if you're not familiar with how KMS works, they all work the same way. It's a remote API that can generate and store keys and also execute cryptographic operation. So actually, cosign is not going to download the key locally and use it to sign the image, because that would be very stupid. It's actually pushing the image toward the service and asking the service to sign the artifacts and then downloading the signature. Make sense? So if I go back to my console and I refresh, now I have 2 artifacts. And in the second one, if I look into it, it's just basically a JSON payload. And inside the JSON payload, I have my signature. So that's the unique signature of this specific container image. Then what I can do, so this is part of the, you remember establishing trust, zero trust thing we talked about? This could be a step that you do in your build pipeline, which is you build your artifact, and then you just add a step to sign the artifact and store the signature. Then later on, in the next step, which is maybe the deployments or the QA or whatever, I can just use cosign to basically do the same exact operation, but in the reverse order, which is verify the signature of the artifact. Same thing, cosign, verify. I give it the key I want to use to verify, and then the container image I want to verify. And it will run, and it's a standard Linux tool, so it will exit with 0 if the verification have been successful. It will exit with non-zero if the verification have failed. In this case, it said the cosign claims were validated, and then the signature were verified against a specific public key, right? So this is establishing trust. Now, if you want to go further, I'm not going to demo the SBOM things. I want to leave time for questions if you have any. So if you want to go further with cosign and SigStore, if you're using Kubernetes, they have an admission controller. Those of you who know what Kubernetes is know what admission controller is, hopefully. Those of you who doesn't know what Kubernetes is, admission controller is a little police officer sitting at the door of your Kubernetes cluster, and you tell it a policy, and it will enforce the policy, right? This is a very stupid way of explaining it, but the point is it's a thing that can enforce policies. So you can deploy the admission controller, which is a component. You create a policy like this that says cluster image policy. The policy will apply to all the container images, and then you just give it a key. And essentially what it does, if you ask Kubernetes to deploy a container image, it will look at all its admission controllers. It will see that it have one deployed. It has policies attached to it. It will pass that container image to that policy and say, is this OK? Can I deploy this? And if it's if the verification go through, it will be deployed. If not, it will not allow to deploy. Straightforward? Clear enough? OK, perfect. So yeah, so that's like very simple demo for cosign and SigStore. There are other tools I didn't download. I didn't show. There is a tool called Sift that you can use to generate SBOMs, and then you can also use cosign to like sign the SBOMs and verify them if you want. I know that Docker also has an experimental command to generate SBOMs. There are already a bunch of other providers that just generate SBOMs automatically. A question I get asked all the time is whether generating the software bill of material should be something that you do at your build pipeline level, or is it something that's better suited for the artifact registry itself, which is essentially you push your container image to an artifact registry, and the artifact registry itself does the generation of the SBOM? That's a very good question. It's whether you want to trust your artifact registry to execute compute or not. In my opinion, an artifact registry is something that just store artifacts. Making it generate SBOM sounds kind of stupid to me, but that's just my opinion. I think SBOM generation should be part of your build pipeline. Very quickly before we move on, we have a bunch of, if you're using Google Cloud, maybe you would care about these kind of things. We have a set of products that we call the Software Delivery Shield. This is not a sales pitch, this is FYI. Use them or you don't. It doesn't really impact my salary, so I don't really care too much. So we have our own CDE, Cloud Development Environment, called Cloud Workstation. This is just a remote workstation in the cloud. I think you probably haven't realized that, but I am not actually developing on my laptop here, or I'm not doing the demo for my laptop. If I show you name, this is a Linux box, right? I'm on Mac, so I'm actually using Visual Code to remote SSH to a remote workstation, because the best way to not leak code is not to have it on your developers' laptops, right? We have a component called Google Cloud Code Source Protect. So part of what I talked about earlier of like shifting awareness left and making sure developers know what they're doing. This plugin, which is free, it works for Visual Code. You can just download the plugin and install it, and it does support Python, Java, and Node. And what it does basically, it has an ongoing vulnerability scanner. It scans your dependencies as you are writing code, and it just reports them directly in your IDE. So as a developer, I know whether a certain dependency that I'm using has vulnerabilities or non-vulnerabilities or not. Completely free to use. We talked about artifact registry. It has built-in vulnerability scanning, so that's not new. Everybody does that these days. But there is another thing also that is free. It's called assured open source software. So assured open source software is a set of Java and Python known libraries that we are fuzz testing and providing for free. So we take those libraries, we test them for vulnerabilities, we do some fuzz auditing on them, and then we just completely for free for anybody to use. It supports only Java and Python for now, but they're adding Node.js and a bunch of other programming languages. And that's all I have for you today. Thank you very much. I think I have 5 minutes, right? 5 minutes? I didn't start the timer, but yeah. Questions? That's a very good question. You would go, I wish I had the SBOM when the log4j vulnerability was announced. Because one of the things that happens in a lot of organizations is that you're probably using GitHub, and you probably have a GitHub organization with hundreds or thousands of repositories, right? You're not doing monorepo, unless you're doing, are you doing monorepo? No, so you're doing not monorepo, right? So the issue when you don't have monorepo is that if you have a vulnerability in one library, how do you actually scan your entire GitHub organization to answer the question, where am I using this library, right? Maybe GitHub have some bots that can do that, but if you have SBOM, one of the ways I'm working with some customers on kind of considering how to use SBOM is to use it as a big data problem. You generate SBOM, store it in a warehouse, and then later on we can query the data warehouse, not literal warehouse, the data warehouse, and then later in we can query the data warehouse and say, where do I have this version of this library, right? So that's just one simple example. Also, yeah, that's a very good point, thank you. License checking. So am I using Terraform? Am I violating HashiCorp new business BSL, whatever business source license? That's another question, another point. And I'm not picking on Terraform here or HashiCorp specifically. I'm just giving an example of, or am I violating Redis license? Because they have also changed the license, or they threatened to change the license there very recently, a few years ago. So, or generally speaking, maybe your company has a policy to not use certain licenses, right? I don't want people to use GPL version 3, for example, right? That's a very debated license in the open source space. So that could also allow you to say, like, am I using something that uses this license or not? Although that technique can also be done through static code analysis, but SBOM is also another way we can do this. Any other questions? Yes? Yes. To be honest with you, I haven't dug into that specifically. In my opinion, SPDX is slightly easier to read. Let me run this command and see if we can get it to run before the end of this session. And hopefully I can show you how the SPDX format looks like. But the TLDR is I haven't really looked into the difference between those, so I don't know. So this is how SPDX looks like. Sorry. Let's just do it here. So this is how SPDX looks like. It's essentially just like key values. It's slightly easier to read. This is SPDX generated for a container image. So it actually unpacks the container image and looks at every single file inside the container image. Any other questions? Either this was very clear or no one understood anything I said. And that's actually concerning because I still have 3 more talks. All right, I hope this was useful. Thank you.